putting in the social network
Good.
for people to see the opening.
Yeah, opening will also be on YouTube.
Yeah, through YouTube.
Yeah.
Can we get the test? Test?
Are we going to allow questions after the?
No.
Because I need to maybe to remove the last slide because I have the question.
Okay.
But I will leave it and say questions during the record break.
Okay.
All right.
One minute. 1, 2, 3.
Past 9.
Yes.
Wait.
Yeah.
Yeah.
We'll wait for 200 people.
Okay. Okay.
Yeah.
Just you have to close your microphone. Okay.
Let's see how close. 1, 2, 3. 1, 2, 3.
Stićemo publishing.
1, 2, 3.
Biti jasan da ako ne odgovore.
Nema.
1, 2, 3, no.
S tim da
Radio.
kaj si im do 17, odnosno 18
Da.
dozvolio.
Da, tjedan dana je
17 pitanja, 18
Da,
još odgovor.
tako je, da. Tjedan dana duže.
Yeah, I think so. Yeah.
Radio. Yeah.
A little bit, okay. Sure.
Okay. Yeah. Znači tu shvakat su za promjene prezentacije i takve stvari.
Znači tu ćeš mijenjati.
Ja ću mijenjati sad.
Aha, nećeš od tamo negdje.
Ne mogu.
Ne možeš, dobro.
Skočiš Nataši za...
Dobro. Aha, okej.
Never.
Yes.
To whom can we ask to take 2 or 3 pictures immediately?
This guy is in charge of photos.
But that takes time.
That takes
Because
time.
I want to put immediately.
Anton, can you
Just with the iPhone to.
take a photo with iPhone? Yes.
When we are speaking, do you, and after you share with me.
Sure, I can send, for example,
To Neven and in the opening ceremony and during my talk.
Telegram. Which do it for real.
Pictures, so I can put in the
But
Twitter.
maybe if you want
immediately.
one now to put immediately, or
We can put one now of the two
Yes.
of us. Like working
Recording in progress.
yes,
behind the scenes.
for a photo, maybe yes.
Yeah. Like we are arranging some of
No.
the last details.
Yeah.
It's a lot of people.
Well, as I said, I expect maybe 200 to be at the opening. Just one photo so we can put it on social
Da
network.
bude, gledaj, sve došli 100 ljudi.
We should
Na
do
live.
a more formal picture, like we are.
Shall I stand up?
Yes, like
Okay.
we are looking at the final details
Okay,
of everything. Okay, is the networking?
Yes, finally we have wired network working.
Yes. Did you put another system or use the system of the hotel?
We use the system of the hotel. Yes. And I think now even Wi-Fi works reasonably well. Yes. Okay, I think we have hopefully enough pictures. Okay.
Choose.
You'll send them to me and I forward. Okay. I think we can wait a few minutes. So we have 258 people registered up to now. And I would guess that's a good number. They're not coming
The
through.
mayor is not here yet, so
Okay.
maybe we'll wait a few more minutes.
Yeah, we wait up to 15 minutes. We can wait,
Yes.
and then even if he didn't come, we go.
No, the secretary.
We'll walk around, and when there's no more people in the lobby, you can start.
We have to wait for mayor.
For the mayor.
Yes.
Okay, no
Yeah.
The mayor, yeah.
Yes. So we
Don't
will wait
forget the mayor.
15 minutes, or until he comes.
His
Oh.
secretary called me on Friday and confirmed that he's coming, and I told her to say
Is
that
the
he has
lady?
to be.
The
It's
mayor?
no, it's a man. But his secretary called me on Friday and confirmed that he's coming, and I said to her to convey the message that he
Okay.
needs to be here by 9, even before, but before obviously is not
Not.
the case.
Do you want to call the secretary?
I don't
No.
have the number, but
You don't have the number.
my rector knows his direct number, so in case.
Okay, maybe.
Have you met him?
No, not yet. Let's. The numbers are here now. Only the mayor is missing. čekamo gradonačelnika Pafosa, ali maksimum 9:15, onda bi morali krenuti zbog programa. Da. Aha, u komunikaciji smo, vidio sam da ste posle, nisam stigao pogledat. Da. Eto, budemo to. Molim. Any news?
The line was busy, so. But, okay, until we cover the first one, maybe.
Well, I suggest we start at 1:15.
Yeah, in any case, yes.
In
If
any
he's here or
case,
not.
if he comes later, you can always ask him to give a welcome.
Okay, yes, yes.
Because we don't have more than 15
Yes,
minutes
yes, yes, yes.
flexibility.
And where are we going for the photo?
I don't know yet. It depends on weather. Probably the weather is not that good, and maybe we'll do photo tomorrow.
Ah, let's see.
Aha. More. Dobro. Super. Da. Da. Dobro. Dobro. Da. Pa, to sve možeš reći.
Is still this one, the mayor?
Fedonos, I don't know.
The name is different. I
Different.
know is a different way to write it, probably.
Could be. Yeah, Phydonos, it's Fedonos. Yes, yeah, yeah. The mic is working. How to turn it off?
The mayor is here, so I think in a few minutes we can start.
We can start. Okay, perfect.
So
Okay.
this went to
No.
bring him.
Okay. Okay.
appropriate way to write it.
Yeah. So, you can start.
I will start. Good morning, everybody. We may start this opening session. First of all, welcome to all for this 17th in-series conference of SDEWES, which is, as you see on the title, Sustainable Development for Energy, Water and Environment Systems. These are the organizers. Most of them you know very well. This year, because of the presence of this conference in Cyprus, we have also the Cyprus University of Technology to be one of the main organizers. Just a little note about the International Steering Committee, which consists of 40 members. Actually, the latest list that we have that was announced last week is that almost half of the members are in the top 2% scientists, and this is the list published by Stanford every year, and which is a good success for the International Steering Committee that handles all these conferences and the series of conferences. Okay, these are the basic sponsors, various companies from all over Europe mainly, so I will not spend more time on this. The participants are coming from all over the world. However, most of them are from Europe, as you see on these little slides. We have 500 participants coming from 52 different countries in this conference, 215 cities, and more than 270 universities. Quite closer, okay. Sorry. In that case, I may need to move. Okay, thanks. In 270 universities, all numbers are quite big and quite impressive, to say the truth, for a conference on these themes. These are the flags of the various participants. As you see, a lot of countries participating, and you may identify your own flag on this slide. Right. Just a quick mention on the SDEWES series of conferences. As you see, we have number 1 to 17 total conferences in total. Started in 2002, so it's the 20th birthday, let's say, of the SDEWES organization until now. In total of 17 conferences, as we said. You can see the various years that these conferences were taking place. And now we move also the conferences away Europe. As you see, we have the Latin American conference, and the AP stands for? The AP?
AP is Asia Pacific.
Asia Pacific also one conference just made, which is also another, let's say, extension of the conference to that part of the world. Okay, some statistics. As you see here, we started in 2002 with 35 countries. Now we have 52, and this is just for Paphos. If you take the total, not the last one, but the previous column, that one here, which is the total of 2022 until now, we have 63 countries, 870 participants, presented 780 papers, 1,200 almost paper submissions, and okay, the attendance rate is 1.44. Okay, these are the papers published so far. Actually, one of the success of this conference is that we publish a lot of special issues in various journals. This shows the quality of the papers presented in this conference. You may identify a lot of the journals. So, okay, the figures are quite small because there are so many. However, you see the list also here, and all of them, or most of them, are good quality journals. Some of them in Q1 category, which shows the importance of this and the quality of the papers presented. That is quite good. We have also our own journal, the Journal of SDEWES, with Professor Niven Duic being the editor-in-chief. It's online since 2013. Publisher is the SDEWES Center, and is now indexed in Scopus, Inspec, and the others that you see there, Google Scholar, Croatian Web Archive, and so on. The side score of the journal is 4.5. We got that in 2021. We're expecting next year to receive an impact factor from Web of Science, and we look forward to it for the first impact factor and hope to be a good value, a good number also. Okay, about the conference rules, I will ask Tomislav to say a few words. Where is he?
Okay, thank you. I will try to be quick and give you a few SDEWES rules about publishing and presentation, and just to give you a few practical pointers about the activities that we plan the next 2 days. So I'm very happy that the numbers of on-site people in our conference is growing, which is very good. It means that we are slowly returning to pre-COVID times. However, we still have a lot of people that are following us online that were not able to come to Paphos. And that's why we are continuing with the virtual conference. Because in a way we want to allow all the people the same conditions and the same level of access to research and papers that are being presented here in Paphos. But that's not the only good thing about the hybrid part of the conference, because it actually allows the people that are here in Paphos as well to go into the hybrid part and to check presentations that they might missed or they didn't have time to go to. Also, the hybrid part of the conference allows you to have much deeper and I would say better discussion than you might have in the physical session room, because you just don't have time to do it. So this hybrid part is something that we find very beneficial and that we plan to continue. One thing that is very important is the interactivity of the hybrid part, which means asking questions, answering questions. The hybrid part of the conference actually started yesterday, and it will continue till the 17th for questions and comments. And it will go to the 18th of November for authors to give their final response. It is crucial for you to answer questions that other participants had about your paper and your research. The similar rule applies for all the people that are physically here and presenting their paper here in Paphos. It is very important for you to present your research. In case the research is not presented or the questions are not answered, we will have to remove your papers from the proceedings, and you will not be able to go and be invited into special issues for one of our journals that Soteris mentioned a few minutes ago. So this is on publishing. Just maybe a few pointers for you. We will have lunch every day here in the hotel. The lunch will be downstairs in a designated restaurant just for our conference participants. You got your lunch coupons on your name tags, so you have it for each day. The coffee breaks will be right in front of the registration, so it's quite convenient. All the rooms are here on the ground floor, so A, B, C, D, and E, and F, G, H, and I are on the first floor. Everything is quite close, so I don't think you will have any problems of finding it. Just follow our instructions. Regarding the social trip, we have a very tight schedule. We have prepared a lot of activities for you tomorrow. So please be punctual and on time so we can start with the trip on time. The official time is 1:30, but we will start filling the buses at 1:15, so please try to follow the schedule. The detailed information will be at the registration desk today afternoon, tomorrow morning. If you have any questions, you can always come to the registration. We would be more than happy to answer them. For all the people that are not here in this hotel, that are in the Basilica, you have a shuttle bus. The timetable for the shuttle bus is on the conference webpage. It's 8:15 in the morning, and it goes after all the activities here are done. But for any deeper information, you can always go to the webpage. Okay, I think this is more or less what I needed to cover. For any questions, any problems, you can always come to us at the registration desk. We will be more than happy to assist and help you with anything. So I wish you a good and successful conference, and I give the word back to Soteis.
Thank you. Thank you, Tomislav. Okay, that's for later. We'll start with some welcome addresses. I will first call my rector, Professor Panagiotis Zafiris. He's director of the Cyprus University of Technology, to say a welcome note to everybody. Okay.
So welcome to Cyprus and beautiful Paphos. It's a pleasure to be here at this special conference on sustainability. Our university is relatively small. It has 3,000 students. It's in Limassol primarily, but recently through collaboration with my friend, the mayor, who will be talking right after me, we have managed to bring one of our schools here in Paphos, the School of Tourism Management. And we are building strong collaborations with the city here. And I think you'll have the pleasure to explore it and get to know the city and its people. And I think that will definitely give you a positive memory from this specific conference. I would like to congratulate my colleague, Sodiris Kalogiru, who is leading the organizing committee from what I noticed. And also, of course, everybody who has been involved in this conference for its success. With Sodiris, Sodiris is actually leading our effort to join the European University of Technology, which is a project under the European Universities Alliance scheme of the European Union. This brings together 8 universities, all technical universities, from 8 different countries and 8 different languages, from what I remember. One of the initiatives of this alliance is actually to strengthen the sustainability policies and practices within the universities that are involved in this effort. And as far as Cyprus University of Technology is concerned, we are the only state university which has a dedicated office on sustainability. We are the only university that has a number of horizontal committees that are looking at all these issues, and we have been very active in terms of sustainability within our university, and within the cities we are actually hosted. One of the initiatives that is coming up from this alliance is a new bachelor program in the area of sustainable development. And you can imagine students being able to travel across 8 different countries, explore and collaborate with different cultures and different schemes in terms of sustainability. And we want to give our students this opportunity, and we hope we will be able to announce something around this topic in next year. So congratulations for this conference. I wish you all the best. Thank you.
Thank you very much. Thank you very much. The next welcome address from the mayor of Paphos, Mr. Fedonas Fedonos, very good collaborator with the university, as you've just heard. So, the floor is yours.
Good morning, Mr. Rector, Mr. Kalogiru, professors, students, ladies and gentlemen. I am pleased to welcome you to Paphos and to this conference focusing on sustainable development of energy, water, and environment systems. The overall vision of Paphos municipality is to work towards achieving a better and more sustainable future for all. Therefore, the domains of energy, water, and environment is one of an utmost importance. Currently, the city of Paphos is implementing a number of smart projects that are tailor-made to help achieve this vision. During the past year, the municipality of Paphos has made a significant effort to upgrade existing infrastructure and services while creating new solutions to improve the quality of life of its citizens. For example, the last 3 years, the municipality has proceeded with the digitalization of the several services, online application, historical documents, etc. In terms of the Smart City project, the municipality has already implemented the infrastructure responsible to collect the data from Smart City applications. More specifically, this infrastructure is based on LoRa 1. Furthermore, the following projects are operational or under implementation. Smart parking focuses on reducing CO2 by 20% due to the reduction of the traffic. Paphos is the first city in Cyprus to proceed with a total establishment of a pioneering combined system of smart parking for 3,300 spaces around town, incorporating all municipal parking lots as well as individual street side space and including sensor connected to a mobile app to allow citizens to search for free spaces and to make also a pleasant activities such as pay for parking spot online and easy. Smart street light focuses on reducing energy consumption, which reduce both the amount of fuel needed to generate electricity and the amount of greenhouse gases and other air pollution emitted as a result. Currently, more than 7,000 street bulbs have been replaced with smart and connected LED lights, and currently the reduction of electricity consumption is more than 53% already. Smart poles measure environmental conditions using the installed sensor. LED monitors will inform the citizens about this condition. These monitors will be used also to raise citizen awareness about environmental issues. We have already installed 55 smart poles in the city of Paphos. Smart water management includes the supply and installation of equipment, including 30 or 31,000 of smart water meters and software, as well as services for the upgrade of all the existing system for the implementation of an integrated water resource management system for the municipality of Paphos. Development and maintenance of the Geographic Information System, GIS, will be delivered in the next 20 days. Furthermore, the municipality of Paphos has set as a strategic goal the development of the sector of higher education, innovation, and digital technology, an area that will act as a third pillar of economy, business, and social activities in the city alongside with the tourism and land development. This venture is not limited to the narrow geographical and population boundaries of Paphos and Cyprus, but has a regional nature since the proximity of Cyprus to the countries of the Middle East and North Africa offers the possibility for our city to function as a regional hub for the development of education, innovation, and research in the wider region. Cyprus is the nearest point of the European continent to the Middle East and North Africa area. At the same time, Cyprus has excellent relationship and collaboration with countries like Egypt, Jordan, Israel, and Lebanon. To this end, we have already taken significant steps. The internationally accredited American University of Beirut, AUB, established in Paphos the American University of Beirut Mediterraneo, a university with at least 3 schools. Also, as Mr. Rector mentioned before, Paphos municipality signed an agreement with the Cyprus University of Technology to establish the School of Tourism Management, Hospitality, and Entrepreneurship that will consist of 2 academic departments and an institute for a tourist professions. Both universities will start delivering course next summer, next September, as we discussed last week with the rector, Mr. Panagiotis Zafiris. Dear all, I will not take more of your valuable time. I would like to congratulate the organizers of this conference, especially Mr. Kalogiru, for their professionalism, and I hope that you will all have a constructive conference and a pleasant stay in our city. Thank you.
Thank you very much, Mr. Mayor. The last welcome address is from Professor Maria da Graça Carvalho. She's a professor, as you hear from the name, but also a European Parliament member, so we'll forward your introductory note.
So, good morning, dear Mayor of Paphos, dear Rector of Cyprus University of Technology, dear Professor Kalogiru, dear Professor Nevenvich. It's a great pleasure and honor to be again present in the SDEWES conference after such a difficult period of 2 years and a half that the participation was mainly remote. So I also want to welcome all the participants and everyone that is following us online. I have been present and an enthusiastic supporter of this SDEWES project since the first moment. Actually, it was something that Nevenvich and Professor Naim Afghan and me, we designed this idea probably 21 years ago, and it starts 20 years. So actually, as you, Professor, have said, this is the 20th anniversary of this SDEWES adventure. And I want to congratulate Professor Nevenvich and all his team, because it's a tremendous work. And I want to congratulate for the success of the SDEWES conference, but also all the related activities. I'm always very impressed with the amount of publications in journals related with this conference. That is one of the indicators of the quality of the papers that are present in these conferences. I want to thank our local hosts, the Cyprus University of Technology and its rector, Professor Soteris Kalogiru, the chair of the organizing committee, the mayor of the city, for receiving us in such a beautiful town. And as we say in Portugal, with such a smooth weather, that is a fantastic, coming from Brussels, is a really positive shock to arrive here in a very nice weather. So thank you for all the locals, and congratulations for a very nice welcome that you have done to us. And welcome to all of you, especially the ones that have traveled, and I know that some have traveled quite far away. And to tell, and also a special word to the newcomers. There are some that are newcomers to the SDEWES, and I want to tell you that SDEWES is like a family. Once you enter, you will not go out. You will be keeping coming to, as you see, we'll see in one of the wards, you keep repeating because you really like it, and it's very good for your professional career and also for your personal relations. You do a lot of friends in the SDEWES conference. And I would like in this short message to leave you with two points. First one is when I look to my CV and my list of publications, and if you ever have done so, you will notice that most of my co-authors come from the Balkans. And why is that? I'm professor in Lisbon, and was when I was a young professor in the 90s. There was the trouble and the war in the Balkans, and we have received, together with many other universities in Europe, like in Germany, UK, we have received researchers, young professors, PhD students from the Balkans. And I was lucky enough to receive several of these. The first one was actually Professor Naim Afgan, and after him, several ones came to work in my research group, like Neven, Dwitch, and was very important for me, for my career, but also I think very important for them, that didn't need to interrupt their work. They continued to do their research work, and they were able to go back when things settled down and help to build a strong democracy regimes in their own countries. That is why I have in the European Parliament asked the Commission to do similar schemes, and now we have similar schemes in place to Ukraine, ERC for Ukraine, Horizon Europe for Ukraine, Marie Curie for Ukraine. But now I'm asking, and I've been asking in plenary, that the European Commission has a scheme, a general scheme for all the researchers at risk, that we don't do it just when there are a war, but that we have a permanent scheme, that we can help researchers that for some reason have trouble to continue their research work in their own countries. And I'm thinking about Iran or Afghanistan or wherever that they feel like they would do in a more peaceful and safer way their work in Europe, that we welcome them in Europe. And I'm also asking all of you, when you are looking for PhD students, collaborators for your projects, that you keep these in mind, that are researchers all over the world that need a peaceful and safe place to work. And my last word I want is to remember three dear colleagues that have contributed a lot for the SDEWES conference and unfortunately left us in the last 2.5 years. That was Professor Naim Afgan, Professor Mário Costa, and Professor Tosh de Azevedo. The two last of them, Mário Costa and Tosh de Azevedo, they left us very, very young. So our thoughts are with their friends, families, and the best way to honor them is to continue to work and keep their legacy alive. With this, I wish you a very good work, and I hope that in the middle of this busy schedule that Neven has put on us, you still have some time to enjoy beautiful Paphos and this fantastic weather. So thank you very much.
Okay, thanks a lot. Okay, we heard so many times about this island, so I will start this keynote presentation first with a few things about Cyprus. Beyond the word welcome, just to mention that you are in a country that has a written history of more than 10,000 years until now. It's one of the oldest written histories in the world. Occupied for many, many years, as you understand, from ancient times. And actually, this location of Cyprus, which makes it very good, is also very problematic. Being in between three continents, Europe, Asia, and Africa, just opposite the Suez Canal, very near to the holy places. So at the times of Crusaders, everybody was occupying Cyprus first and then going to the to the holy places to freedom, the places that Jesus used to live. However, we have this nice history and also nice archaeology here. So I will start by giving you some hints about the places you may visit during your stay. If you have the opportunity, it would be nice. This is Cyprus, where you see the red arrow on the left side of the screen, where that little circle there is called the Coral Bay area, I would say. And starting from the way coming from Limassol towards Paphos, the first thing you can see is this Petra to Romiou, we call it in Greek. This is also, I must need to say that from the ancient Greek mythology, Cyprus was the birthplace of Venus, or in Cyprus, in Greek we call it Aphrodite. Aphros is the foam when the wave breaks of the sea, so it's supposed to, the Venus, which was the goddess of love and beauty, was born out of the foam of the sea. And this is the place that is supposed to be born, this large rock there, and you see the arrow, it's a bit on the, let's say, towards the eastern part of the Cyprus. Moving on to old Paphos port and the Paphos area in general, they have a little nice port there from the medieval times, and also one very nicely preserved Asian park where, first is the castle, which is nearby the old port, and also this is also the promenade of next to the harbor, very nice and very little shops there. You can spend your time if you have some way of visiting. I think there is also a bus going there from here, so it's a good opportunity if you have a little time to visit the area. Also next to that is the Paphos Archaeological Park, where there are a lot of houses of the Roman times, I must tell you, with lots of those mosaics. This is one of the famous ones, and ones that I like more, is showing Ikarios, which was the first man on earth supposed to have made the wine. And of course, as you see, the other says, I proti inon beyondes, the first who drink wine, and obviously they get drunk, as you see from the from the mosaic there. It's a very nice and very preserved area, nicely good idea to visit if you have the time. Okay, moving towards the north from here, not far away, is the Lara Beach, where we have the birthplace of these little turtles, the green turtles of Mediterranean. They come to the beach, they dig the sand and lay their eggs there. So if you go there and see things like this, it means that this is a turtle nest, and you should not try to see the eggs below, because you'll destroy them. So keep away of it if you want to see. But it's a very nice beach also if you want to take a bath there. It's a beautiful water and very nice, as you see, white sand as well. Now, on the other side of the island, going towards, you see the little map on the other side of the Akamas Peninsula, it's the place where Aphrodite used to take her bath. So it's a very beautiful area. It's a cave where you see the water dropping like a shower, and the mythology says that there was the baths of Venus or of Aphrodite. And also this area is a very beautiful area. You can see from this little shot here. Akamas is a very preserved area, I would say, at the moment at least. And it's nice to visit if you have the chance. Right, this is just as an introduction to this conference. Of course, best wishes for a successful conference. A warm welcome to everybody, and I hope you will enjoy both the trip tomorrow afternoon and also the beautiful parts of Cyprus that I have just shown to you. Okay, moving on to my main presentation. Now I'm going to talk about renewable energy systems. I'm going to talk actually about the current status in the world. We'll say how much we put of those renewables until now, and some prospects. You see that I have many hats, as we usually say in Greek. One of them is that I'm the editor-in-chief of Renewable Energy Journal, so as you understand, this is my area, and this is where I want to show a few things. Before I go into the details, I must say that I feel very happy this time of the year, this period. And the reason is that everybody speaks about renewables nowadays. It's a pity that this comes because of a war or because of the very drastic climate effects we see every now and then on the planet. However, let's take this into an advantage and do more and install more renewables in order to make our planet greener and more safer to the generations to come. Okay, this is the outline of this presentation. We'll start with a short introduction about climate change. I'm not a climate engineer, I must tell you. I will show some facts that proves that something is going on with the climate, that we are responsible as human beings. Then I'm going to say a few words about the status of the various renewables. And in all of this, I will talk about prospects and new research and so on. I think we're all convinced nowadays that something is going on with the climate. We see things like this in the news almost every night, and disaster here and there, floods here and there, hurricanes, melting of polar ice, and so on and so forth. It's things that we are responsible as human beings. It's proven at least. A few years ago, we were using the term global warming to represent what is happening. Nowadays, this is not correct anymore, and the most general term of climate change represents better what is happening, because we don't have only warm summers, we also have very unstable winters as well. And it doesn't matter if you are living in a very developed country like Germany, you see here, or in a developing country like India. The disaster is the same, the frustration of the people is the same, the problems created are the same. And nowadays we even have the term climate refugees, representing people that have lost their properties because of the climate effects. It's a serious thing. It may not happen to you yet. It will happen one day, not to you, to all of us. I mean, we're living in this planet isolated from the rest of the universe, and at some stage, if we don't take measures, will happen to us as well. Now, we will try to see a little bit more scientifically the way it looks like. This is a temperature anomaly and CO2 concentration representation from the Vostok ice cores in East Antarctica. Korean scientists went there some years ago and took samples of the ice at the period that these ice were deposited, and they tried to represent the climate in these last 400,000 years. As you see, every about 100,000 years, there is a peak. And so the people that they don't believe that something is going on today, they say, okay, why you should worry? We are in another peak. It will go down soon afterwards. Yeah, this is correct in a sense, but if you take this line here, which represents the CO2, it was in the, it's not very good, this one, and the thick line is the one which represents the CO2. It was never above 300. But nowadays it's more than 400, which means that something is happening that we are responsible for it. If we try to see what's happening the last 1,000 or so years, you'll notice a figure like this one. Everything was nice and smooth, below 300, below 290 ppm actually. And suddenly something happened. What happened actually was the Industrial Revolution, where we developed the steam engine originally, and then the diesel engine, burning huge quantities of coal and then diesel fuel to satisfy the needs of humanity. And of course, this created all of the fumes that go to the atmosphere and create this problem of CO2. If somebody wants to see the value of the current value of CO2, you can visit this website here. I did this a few months ago, I would say weeks, but it was months, it's May 2022, and you see the figure is 421, much higher than the 300 or the 400 limit I have shown before. This shows that what we do as human beings, as burning these fossil fuels, creates the problems of our planet. It creates this unstable weather that most of our people and our compatriots, in a sense that we are all living on the same planet, are facing. So the idea is to move toward renewable. And before going into the details, I would like to show just one slide to show, because another problem is the reserves. We don't have unlimited reserves of fuels. I believe that we will stop using fuels much earlier, before these reserves are depleted. However, even if we get use completely of them, you will see that coal will last another 140 or so years. The crude oil and natural gas around 50 years. You may notice that these figures have not changed in the last 20 or so years. And the reason is not that we spend less, but because we found some new resources, for example, the shale oil and the shale gas that they take out of these special rock formations under the ground. They can create oil out of it, and this could help the reserves to last a little bit longer. However, this is not the problem. The biggest problem is related to the environmental effects I have just shown you before. And actually, nowadays, China and India are the most polluting countries. They burn huge quantities of mainly coal to satisfy a lot of population that lives in these two countries. China, although it leads the world in the pollution, it's also leading the world in the renewables, as I will show in the following slide. slides. So what we would like to have is to avoid having these kind of things. These huge quantities of foams going to the atmosphere, polluting the planet, polluting the climate, changing climate, and changing the way that this reflects on the way we live on the planet. Right, moving on to the main subject of this presentation, we're going to talk about renewable energy systems. Here we're talking about solar thermal power or solar power in general, either solar thermal or photovoltaics, hydro systems, wind energy systems, biomass, biogas, biofuels, which is this large family of fuels that comes from mainly from wood residues and so on. Before going into the details, I would like to show you the current energy indicators for 2021. This is the latest international statistics we have. And as you see here, for the first time, the total installed power of renewables exceeded the 3,000 gigawatts. And if we try to exclude hydropower, which is 1/3 of that, it goes down to about 2,000 gigawatts. Quite a good figure. However, it will improve in the coming years. Some other noticeable figures is this installed capacity of PV. For the first time, the PV capacity is more than the wind, which is still at the high value, 845 gigawatts. And of course, we should not underestimate this 1.5 exajoules of solar thermal power as well. This shows the global overview of renewables in the world as a total, and you see the previous years as well, but let's take only the current year, which is the the mouse can be seen much easier. You see that nowadays the modern renewables is only it's a low value, 12.6% of the total of the energy demand or energy consumption of the planet. The situation with electricity is a bit better. Okay, this is to show you this thing, and the share of renewables in electricity is now 28.3%, quite a good figure, I would say. You see also the rest here. Fortunately, only 10% is on nuclear, and another 62% which goes on the other fossil, or the traditional fossil fuels. And these are the values for the 2021. One of the problems that people some years ago faced was what happens if we have a lot of renewables in the grid. We know that renewables are not steady, are variable. They have this intermittent nature. Now it's day, after a while it's night. The wind sometimes blows, sometimes doesn't blow. So we have these examples here with these countries that have a high percentage of renewables, and especially the first country shown here, Denmark, with my friend Henry Ludian here representing that country. And you notice the instantaneous figure of 117%, which happened and created no problems to the grid, actually. This means that there are ways to solve the problems with storage, converting the available renewables into some other forms, and mainly nowadays we do it with hydrogen, in order to be able to have this energy stored and use it when the need arrives. So there is no problem with the grid and all these things that we are fearing some years ago that may collapse the whole grid is not a case anymore. This slide shows here also how much is the total installed power nowadays, and how much we must do, what we must do to catch the 2030 and 2050 targets that were placed by the International Energy Agency to be able to cover our needs and decarbonize actually the supply. In other words, reduce the emissions to zero. And this shows that we need to increase the actual figure, which is now less than 200 gigawatts for photovoltaics, for example, to 315 gigawatts in the next years in order to be able to catch up with that prediction that was made a few years ago. It's not out of question. I mean, something that is feasible, we can do it. We need to try a little bit more. And with the current, I would say, situation, the increasing values of renewables that we put, I think it is very, very much probable to achieve this. This is also an important figure. This shows the installed capacity, which is the orange columns, in gigawatts, and the energy produced out of that installed capacity in terawatt hours. And this shows immediately the advantage of wind power, which apparently blows also during the night, where all the other photovoltaic or solar thermal that based on the sun in order to operate, it cannot operate half of the time because it's nighttime. This shows the advantage of wind, of course, provided that you have a good wind potential. Another issue that was a problem some years ago was the price of renewables. This slide here is a very important one because it shows the gray area there is the fossil fuel cost range. In other words, the area where the prices of normal fuels occur. And as you see, of course, there is a comparison between 2010 and 2021, about 11 years, of the various renewables shown on top, solar thermal, solar photovoltaics, concentrating, offshore, and so on. And you see that now all renewables are either within that range or even below that range. It means that renewables are cheaper nowadays to produce. They produce energy at a cheaper rate instead of the conventional fuel. So there is no excuse not to put renewables anymore. The second one, which affects also the politicians, and as we have a European Parliament member, it's good to hear, is the permission procedures. We have a declared policy of the European Union saying that we want to install more and more renewables, but on the other hand, all the member countries, almost all, they have so complicated procedures that we need 2 or 3 years to get a permission to put a wind park or to put a photovoltaic, large photovoltaic park and so on. We need to simplify this quite drastically in order to allow more of the renewables to be installed. Finally, another issue is the global investment. If you see that in 2021, more than 2/3 actually, 69% of the investment went to renewables. This shows that people are willing to put their money to renewables instead of the other traditional kind of systems. So there is no, again, excuse not to put more and more in the coming years. The final thing is about the social aspects, and this slide shows that more than 12 million people are working in 2020 in jobs related to renewables. The current figure is believed to be more than 13 million people, which means that also we have a lot of jobs created because of the jobs that open in this field as well. So I will move on by examining the various renewables separately. And we'll start with the solar thermal power. Here we're talking about two types of systems. We have systems utilizing either the solar thermal radiation of light or the radiation or the light of the solar, sorry. In the first category, we have the solar thermal systems, either the low temperature ones, mostly for water heating and industrial process, of course, low temperature industrial processes, and the high temperatures one, like mostly for CSP, the concentrated solar power, and the high temperature industrial processes that require some higher temperatures. The second category using the light, of course, is the typical system is the solar photovoltaics. We're going to see this separately just in the next few slides, starting with the low temperature collectors, just an overview of the various systems that exist. We have the flat plate collectors that are very well known to most European countries now. The evacuate tube collectors, with the main manufacturer now being done in China, and the compound parabolic collectors, which come either in a big bowl or an imitation of a flat plate collector as shown on the figure on the right side, which are steady systems, no need to follow the sun, however they get quite high temperatures. With respect to capacity, you see that this is a success story in the sense that we have an installed capacity of 522. This is gigawatts thermal energy. And there is also a differentiation here about glazed and unglazed collector. The unglazed are used for preheating applications. So most of the systems are using glazed collector in order to satisfy this need. Before going on, I would like to show you, probably you noticed that here in Cyprus, practically on the roof of every house there is a solar water heater which is installed and operating. The white thing you see on the top is a cold water tank because, okay, we have a nice weather, but also we have not a lot of rain, which means that we have interrupted water supply. Now we solve the problem in a way with desalination, not solar, with desalination, reverse osmosis, utilizing a lot of electricity actually. However, all the systems have this white tank which is for storing cold water. So the actual system is without that. But the current figures you notice here, they are talking about 93% of all houses here have a solar water heater which is installed and operating. This is a world record, well above of any other country. The second one is Israel with around 50%, which means that we are doing great in this respect at least. And people here are very much willing to use the renewables as well because of this phenomenon that everybody has a solar water heater on their roof, so there is no problem to put also some photovoltaics or some other systems to get more energy out of the sun. With respect to the collector type, worldwide, the mostly used collector is the vacuum tube, and this is mainly because of applications in China, where they produce this collector at a very low cost. Europe-wise, the mostly used collector type is the flat plate collector. We have a lot of manufacturers, even here in Cyprus, we have 30 manufacturers producing such systems at not a very high price and very feasible, I would say, for people to install these systems. That's why we have all these systems installed in our houses. With respect to research that led to several new innovations, the first idea here is to use polymeric materials, in other words, plastics in a way, for the manufacture of solar thermal absorbers. This is used, you see one photo there, is to reduce cost and due to the lower raw material manufacturing cost, and also reduce weight compared to copper or aluminum that are traditionally used for the construction of the collector. We have also new transparent covers nowadays with anti-reflective coatings for high optical transmission. This improves, as you understand, the performance of this collector. The development also of selective absorbers in order to gain more energy out of the sun and emit lower amount of energy. And the last, I would say, piece of development here is the vacuum insulation flat plate collectors. This is, has to do with the use of high vacuum on noble gases. And of course, as you understand, we are talking about a large area, and if you remove the air out from inside the collector, the glass will collapse, so we need to put, I don't know how feasible it is to see the little supports that comes from the back plate to the glass in order to keep the glass in place. And with this kind of collector, you can have a steady system, not need to follow the sun, and get temperatures of around 300 degrees C, which is a very high temperature for various applications worldwide, and especially in industry. Right, moving on to the high temperature systems, the traditional, I would say, kind of systems and the most mature technology is the parabolic trough collector. These are photos from the installations in the Mojave Desert in California in the early 80s. The linear Fresnel collector, the solar dishes in various shapes and various modes and various ways of doing it in an effort to reduce cost, and the solar tower, where we have a big tower at the center and a lot of heliostats, in other words, mirrors all around, each one following the sun and concentrating the light onto the top of that tower, and as you see, you can get very, very high temperatures. With respect to capacity, the situation here is not as good. You see that we have even a drop in 2021, and this drop is because they dismantle something like 300 megawatts of old CSP in the United States, the ones that they put many, many years ago. However, we're going to see a very huge improvement in the coming years, as many CSP systems are under development in many countries of the world, mostly I would say in Middle East and South African area, where they enjoy a very high solar radiation as well. And all these new facilities have also energy storage, because you know that half of the day is nighttime and we need to store energy in order to operate the systems during the night as well. You cannot install a power system, a very expensive system, and have it idle for all night. So you need to have some storage. And this slide here shows the global capacity of storage. Currently, we're talking about 23 gigawatt hours of storage. This increases, as you see, and will increase even more in the coming years because of those new CSP systems that are under construction. Before moving on, I would like to show you these details about this industrial process heat system. It's a system installed here in Cyprus, in Limassol, in an industry called Kean. Kean is an industry producing juices, and now they even changed their motto into solar juice because they use solar energy to produce the juice. And the innovation of this system, besides the use of parabolic trough collectors you see here, is the use of concrete storage. In other words, the thermal energy collected by the sun is stored into concrete blocks. And I will show you pictures. First of all, the plant room and the two storage rooms are in containers. And this is one of the concrete blocks. It's like a heat exchanger having parallel pipes running through. And the second fluid is not a fluid, of course, it's concrete with special mixtures inside, and you can store very easily the thermal energy there, and that system proved to be very, very effective. And also one of the plant rooms is the plant room, one of the containers, sorry, the plant room, where we actually have the steam generation system. In other words, we use thermal oil passing through the collectors at a temperature of 425 degrees to produce steam at 180 degrees and 9.1 bar. As I said, this is a very good and very successful system already installed, and many companies are considering installing this kind of system very soon. Just to mention that this industry alone is paying used to pay more than 30,000 euros per month for diesel oil in a country that you have so much sun. So we need to use that sun effectively. Some general remarks about solar thermal power. This increased by 3% in 2021. We have almost 300 district heating systems with 1.6 gigawatt thermal in operation by the end of that year. A large solar thermal system, we have almost 1,000 of those systems with 1.23 million square meters of collector area. By the end of 2021, we have 1.4 million square meters of PVT, the hybrid photovoltaic thermal collector. I'm going to talk in a minute about those. And the European PVT market grew by 21%. It means that there is a good market on that field as well. Saying this, moving on to photovoltaics, the basic technologies are the polycrystalline, monocrystalline, and amorphous silicon coming from right to left, and other thin films, which is this kind of substrate that can be used, most of them can be flexible, to deposit photovoltaic material on top of them. Recently, they achieved very, very high efficiency. However, they still suffer from quick degradation of those surfaces. So once this problem is solved, maybe this is the future of photovoltaics. With respect to capacity here, we have a very, very successful story. By the time that the Chinese enter into the manufacture of these collectors and they increase the amount of production per year, the increase of systems per year is quite excessive and quite drastic, as you see here. The curve is quite steep, so it shows that it's more and more every year. And just in 2021, we have 942 total, but just in that year, we have installed 175 gigawatts. If you make a simple calculation, you will realize that we are talking about the equivalent of installing more than 70,000 solar panels every hour. Of course, this is worldwide, but as a figure, it's quite huge. You agree with me. It's a very high figure, and we'll see even more higher figures in the coming years. With respect to capacity, as I said from the beginning, China is leading the world in many of those areas, and you see here both for the installed capacity, because now they produce PVs locally in China, with a very low price, but as you see, it's more than double that the second country, which is USA, with 55 gigawatts. And also the cumulative capacity is China is number one, following by European Union as a total, of course, of 27 countries, and USA third. With respect to the current PV research, we have a lot of laboratories working towards high performance of the cells and modules individually. New nanomaterial applications, both as embedding into the photovoltaic material itself and as a covering of the photovoltaics in order to have self-cleaning of the panels. Advanced manufacturing techniques to lower the cost even more. And as we understand from this figure here showing the Kurnool Ultra Mega Solar Park in India, the trend nowadays is towards very, very large systems. This is the Indian park with 1,000 megawatts. This is not the biggest, however. The biggest is this one here in China with 1,547 megawatts of installed capacity. This is just to give you an idea. It's about double the installed power we have here in Cyprus of conventional power, which means that covering 100% the needs of a country like this one is not out of question. It's very feasible and very viable to do it. Of course, we are talking about an area this located in Mongolia desert, but this is not a problem either for this country. We have a lot of places that we can install such a system. Okay, all right, moving to the hydropower here, this kind of technology comes in a variety of systems with very large hydro, more than 10 megawatts, small, mini, micro, and even pico hydro with 5 kilowatts installed. So if you have a stream of water which flows water continuously, you can have a little turbine there producing those 5 kilowatts continuously. The biggest scheme here is the 18 gigawatts scheme in 3 gorges in China. These are 3 rivers that meet at one place. There used to be a lot of flooding in that area because those rivers were overflowing very often. Now they built this huge dam there with hydro turbines getting 18 gigawatts and also saving the area from the flooding, which is a win-win situation. And installed capacity, you see China is leading the world with 30%, again, as much as the rest of the world, which is also 30%, with second country being Brazil, and the third is Canada and United States. The installed capacity in 2021 in China again leads the world and with 20.6%. Canada and India is coming second and third, and on a different scale you see the other countries there because of the difference, excessive difference between the 350 that is for China with 35 that is for the rest of the world. Wind power, it's another huge area of renewables. Here we're talking systems of offshore or onshore, or building integrated wind turbines, as you see in these little photographs here. Installed capacity is also a success story here, as you see, increasing year by year. The current figure is 45 with 102 gigawatts installed in 2021. 18.2% of those are offshore, and I need to make a note here that the same turbine, when installed offshore, can produce 20% more energy out of it because we don't have the boundary effects. The sea is quite calm most of the time. We don't have mountains, we don't have trees, we don't have buildings interfering with the wind profile, so the turbines there get more power. So it's preferred and also solve a lot of environmental problems that people don't like to see the wind turbines and things like that. You put them on offshore, all these problems were solved automatically. With respect to capacity, again, China leads the world here. You see, I told you that China is going to be the #1 country in the world in various forms of renewables. The rest of the world, 15% and 13.4% the United States, and the other countries that you see here on a different scale as well. Right, the last area is biomass. Here we're talking about the main areas are the biomass, biogas, biofuels like biodiesel. Some people consider waste like municipal solid waste and landfills as renewables, which are not actually. Mainly we're talking here about supplying energy from forest residues and energy crops. In other words, either wood of the leaves of the trees and also animal waste and things like that. Of course, the big question here is, shall we use the land that we use nowadays for cultivating plants for satisfying the human needs for food and put plants that we will do biofuels afterwards? And of course, the solution is not like this. Is to use the land that is not used at the moment for this purpose and maybe put or plant this kind of poplar trees that can get 5 meters high, you see here, in 3 years. So you have a plant cropping and planting of new trees. You can have a continuous supply of biomass to satisfy a lot of the thermal needs of the industry, mainly. However, the main problem here is not biomass, it's biofuel. With all those millions of cars on the streets every day, this is a photo from the United States, with where we have 3.5 million barrels of oil per day required for 200 million cars, huge quantities of fuel that is used just for transportation. So the solution maybe is biofuels, although I don't think that would be the solution eventually. The idea nowadays is to move towards electrification of transportation with electric vehicles, electric buses, and so on and so forth. However, generally the biomass is quite low. It's only 12.3%. The whole biomass, you can see the various categories in heat, industry, transport, which is only 3.5%, and electricity with even lower percentage of 2.5%. Concerning the bioelectricity, in other words, producing electricity out of biomass, you see that Europe is leading the world here, with China and the rest of Asia coming second and third. So with Europe, we are doing a good job in this area. And the main type of fuels are ethanol and biodiesel. The rest are not so much popular, I would say, in this area. Closing down, other forms of renewables as the ocean solar system, where here we have wave, tidal energy, OTEC, the ocean thermal energy conversion. The total capacity is quite low, only 535 megawatts, and it's a 2019 figure. However, the new Green Deal of European Union is targeting towards the ocean energy system because it's an area where there is a huge potential. The problem is that we are talking about areas that are far away from population where it needs the energy, but there are ways to transport energy quite easily nowadays. The other form of good capacity is geothermal, either deep geothermal, which very few countries of the world are lucky to have this kind of resource, getting steam out of the ground directly. And these are some photos from Iceland, where in Iceland 95% of electricity is produced with these geysers. But of course, we can also have this shallow geothermal in combination with heat pumps to install, to lower the COP of the heat pump, requiring much less electricity to operate. And finally, hydrogen and fuel cells. Many people some years ago believed that hydrogen economy is going to be the future. Probably it will be after the depletion of all fossil fuels. However, I think we'll need to move first through the electrification and maybe stay with electrical transportation. We'll see. It's a big question what will happen in 50 or 60 years that all the fuels will be depleted. Some general prospects about the hot research areas. The main purpose of many research laboratories worldwide is to increase the efficiency of various renewable energy technologies, design renewables at the lowest possible cost. We have extensive use of renewables in many regions and many countries of the world now. Some of them even thinking about transforming to 100% renewables. Of course, in order to do so, we need to have a high share of renewables into the grid. Power, we need to do the power system transformation, change the way we think about how to produce energy. And of course, we're talking about storage, integration, and what we call smart energy system in order to have a smart system which will think by itself and decide where to take the energy, where go to storage, go to use, or whatever, to take these kind of decisions. And of course, we are talking about effective coupling not only of electricity, but also of heating and cooling and transportation. I would say mainly for transportation because of the high value of fuel that is required there. This is just a slide to show that, again, China here leads the world with 48% of the buses in China being electric buses. This figure is down to 33 for Europe in 2021. The figures are increasing, and now I think this is the future for most of the, at least public transportation by this kind of means, I mean buses. Finishing off, I would like to acknowledge my sources because all these figures you see are based on some international statistical reports and also from my activities as I told you from the beginning concerning the prospects and the research that is undertaking place. So concluding, as you see, there are a lot of possibilities to utilize effectively renewable energy technologies. We have seen many of them in various categories. These are nowadays more cost-effective options than conventional fuels. We should never underestimate the climate problem that sooner or later will affect all of us, and it's in our hands to use the renewables effectively. Just to show you my email addresses, both the editorial and the university address, and I would like to thank you for the session. Unfortunately, we will not take questions. You can, those having questions, you can speak to me during the coffee break afterwards to ask whatever you like. Thank you very much, and I hope I gave you a flavor of the use of renewables and the prospect that exists in our energy mix in the coming years. Thanks a lot. Okay, you already see that. The next speaker is Professor Niven Dujic. He will talk about the accelerating energy transition.
Thank you, Soteris, very much. Let me try to get this a bit up. Before I start talking about energy transition, I would like to use my other position as Vice President of Croatian Academy of Engineering to greet you. Most of you here are engineers, and we have more or less solved the problem of transition technically. I hope also that the economists, which are also present here, agree with me that we can do it quite efficiently and with economic viability. So the problem is somewhere else. Where is the problem? Why don't we actually do it if we know how to do it? We have a burning question now. Can Europe survive next winter without Russian energy? In 21, EU imported more than 40% its gas from Russia, 27% of oil from Russia, 46% of coal from Russia, and also most of its nuclear fuel was coming through Russia, if not necessarily originating in Russia. What can we do? If we look at oil dependence, some countries were completely dependent on Russian imports. Is it wise to do that? Well, Oil independence, it's a bit easier to solve because tankers are going around the world and you just buy them from one side or the other side if you have infrastructure to import. So oil is something we will stop importing from Russia only on 1st of January, and more or less it will not create a big problem. But interestingly, we are still letting Russia export its oil through European ports and make enough money for financing the war. Is that really wise? What about gas? There are some countries which are extremely vulnerable to gas supply from Russia, mainly Central Europe. We have relatively good solutions to replace 2/3 of Russian gas, but 1/3 will be a bit difficult this winter. These are all the possible options that we can implement, and if we go into simplifying the choices, we can replace 1/3 with LNG imports, a little bit more with pipeline imports of non-Russian gas, around 20 billion cubic meters we can replace with more renewables, 14 with energy savings, and 6 with other measures. That's around 100. And 1/3 will be missing, so we will have to be nice to European industries and reduce the temperature in our homes for 1 degree at least in order to save some gas, because we need these jobs, we need these industries to provide us with enough economic production so we can weather this winter. If we look at a little bit longer horizon, by 25, it's considered that we can replace Russian imports, either with the full implementation of Fit for 55 plan, then with additional energy efficiency measures, adding more heat pumps and electrification of heating and transport, and additional renewable electricity. And we will also need some non-Russian gas imports. We are existing infrastructure. So by 25 we will be okay, but we have 2 difficult winters. On the other hand, the price of renewables has fallen so much. They are the cheapest energy already for 8 years, wind and solar. Gas, this is the pre-crisis price in the States, the electricity from gas. Now the gas electricity in Europe is much more expensive, even more expensive than nuclear. So why aren't we not building more wind and solar? Because we have potentials in Europe. According to Jacobson paper, a recent paper, it would cost $62 trillion to do the full transition to decarbonize society based on wind, water, and solar energy only. It looks a big number, but the payback period is 6 years. So it's really very viable to move to new energy sources, but we are not doing it fast enough. So we solved the problem with the engineers, but we obviously have to solve them better so that those that are making this transition slow really don't have a choice. So we have to improve our solutions. The problem is in barriers. There's quite a lot of red tape slowing down the wind and solar projects. I think Soteris was already mentioning it. It's a major problem. I'm hoping that EU Commission will find out ways how to reduce the barriers between. We need to scale up the installment rate of wind and solar for 3 times. We have lots of vested interests. fossil fuel lobbies, supply chains issues, because our industries are based on old supply chains. We now have to reconfigure them to new supply chains. There will be some of them who will lose the markets. I would like to go back to 2018, Rio de Janeiro, an excellent lecture from Ingo Stadler. And I remember still very well what he said. You know, solving the ozone problem was very easy. Why was it very easy? Because the same industry that was polluting the atmosphere with bad coolants just replaced them with good coolants. And no business model was destroyed. But with climate change, we have to destroy lots of business models that worked for a whole century. And we have to build new business models. And this is what makes it so different. So thank you, Ingo, for this very deep and not so happy message, I would say. I fully agree with that. So why European Union is not unleashing the renewable potential now that it really needs it? We have need for it now and very quickly. And it's so much cheaper than alternatives. We have solutions how to integrate variable electricity. We need more grids. But if we are going to be building grids for 10 years, then we will not do it in time. We need to flexibilize thermal power plants in order to quickly get more flexibility in a short transitional period. We need really good functional wholesale markets coupled on European level, which we finally got, and then a big attack on markets started. And now European Commission is thinking about reforming them, but these markets are working. The price is high because it should be high, because there is no Russian gas available to Europe anymore. So the price should be there. And that should be a strong message to move to renewables very quickly. But we need to start seriously developing demand response and integrate power, heating, cooling, transport, water systems into Power to X. Also, we will need some dedicated electricity storage, but we want to keep that as low as possible because that's expensive. They're saying what happens with when we have a winter windless week in Europe, because then we don't have solar energy also. But it didn't actually happen in the last 4 years. Wind is actually a base load with lots of excess, and everything what is above the red line we can use to electrify heating and transport and produce some hydrogen. So we have to move our energy systems quickly from the 20th century way we were doing things, in which once you turn on the lights, the power plant somewhere in the system increases production and supplies your need, to the system in which demand will follow supply, because supply will be coming from wind and solar. Of course, we will need some time critical supply to cover some of our needs, but we will have lots of needs like heating and transport, which will not be time critical. So this can follow the supply. There are issues on the way. We still don't know for sure what will happen to road freight. It might be electrified roads, or more probably, it looks like battery trucks. They're coming to the market this year. Shipping and aviation long distance cannot be electrified, so we will need new fuels, electric fuels. We will need a lot of research in that area. We are not sure which way the industries will go. High temperature processes sometimes cannot be electrified, so they will most probably be going hydrogen way. We still have to have a backup. Winter windless weeks might not happen very often. The last one was in 2017, but they happen. So we need to have backup. We have to have backup. We currently have backup. We have 1,100 gigawatt of power plants installed in Europe, and the peak is 520. So we don't have to think about backup now, but we will have to think about how to pay for keeping the backup after 2050. It all makes around 20% of energy demand, and biomass can possibly sustainably cover half of that missing demand, and the rest will have to come from synthetic or electric fuels, including hydrogen. So if we look at this graph, this is a very, very simplified figure of how I think it should look like in 2050. We have the red line in the bottom, which is the legacy electricity demand. This is the time-critical electricity demand. We have to cover that. So if we build 3 times more wind and solar than we actually need electricity, we more or less cover in most of the times this critical demand. We will still have some white areas which we'll have to cover by hydro or hydrogen or some other technology. And then the excess, what is above this red line, we can use to electrify transport, heating, and then we still have around 40% excess which we can use to produce renewable hydrogen, which we will use in industry for high temperature processes, for feedstocks, and for fuel production. And in this way we solve the problem. But we know this already like 20 years. I mean, Henrik Soteris, me, were writing about that for a long time, but still it's happening very slowly. There is a lot of story about using hydrogen for everything. You know, a Swiss knife of energy transition. I like this new comparison. You know, you can do everything with Swiss knife, but do you cut your hair with Swiss knife? No, you can do it, but you don't do it. Why? If we look at heating, if we heat everybody with heat pumps with COP3, then we will need around 1.6 terawatt hour of primary wind and solar energy to cover the 5 petawatt hours of heating. If we go through hydrogen, we need something like 6-7 times more primary energy. That means 6-7 times more windmills and solar energy and investment and area and grids. It doesn't make sense because we can easily store heat in hot water and then use it in the times when we need it. If we go through electric methane pathway, it's even less efficient. Then we need 10 times more primary energy. Why would we be doing something so inefficient, so thermodynamically unsustainable, environmentally unsustainable if we have efficient solutions? Thank you very much. And I hope that you will have a great conference here in Paphos. Thank you.
Thank you, Niven. Okay, the next part in this opening ceremony is the award ceremony by Professor Natasha Markowska. She's the SDEWES Vice President and Award Committee Chair, so I will ask her to come to the floor and announce the winners and give the prizes.
Okay. Dear participants, dear colleagues, let me greet you in my capacity of the award committee of the International Conference on Sustainable Development of Energy, Water and Environment System, and welcome you at this award session where we will jointly celebrate and appreciate the achievements of our colleagues who are awarded for their work, who presented the best papers, also the colleagues who published the most cited paper, SDEWES paper, published in one of the journals, associated journals to the SDEWES conference, and also most cited paper published in Journal of Sustainable Development of Energy, Water and Environment Systems. And also we gonna present the award to our most loyal participant. Let us start with most cited papers. What is the metrics behind? So we count the citation of the papers in over 2 calendar years after the publication and divide that number with the impact factor of the journal in the year when the paper is published. So, in a way, we evaluate, we estimate the contribution of that specific paper to the impact factor of the journal. And now, this time, we presented the award to most cited paper from a SDEWES conference held in the year 2017. That is the 12th SDEWES conference in Dubrovnik. The paper analyzes the effects of variation of thermal conductivity in buildings in the Italian construction sector. And the authors are Umberto Berardi, Lamberto Troncinin, Massimiliano Manfred, and Benedetto Nasti. This paper was published in the journal Energies in the year 2018. I know that none of the authors is here with us, but yes, we can invite Benedetto to accept the award, but maybe we have also the first author online. Do we have him? No, okay, he's not with us. Okay, then Benedetto, maybe you can just join me at the stage to receive the award. And also the awardees are awarded with a book written or edited by a member of the International Scientific Committee, and this time it was a book written by Professor Jiří Klemeš. I would like to invite Benedetto, maybe on behalf of authors, to address to the audience, please.
Okay. Okay, so thank you very much for this award. So this is also demonstration of keeping following this conference and all the gratitude for all this work, and how is appreciated with this special communication channel that is the platform of all the journals where you publish your research. So thank you very much again.
Thank you, Benedetto. Congratulations to all and all your co-authors for this great success. Okay, now we can move to the second most cited paper award, and this time this is for the paper published in the volume 7 of Journal of Sustainable Development of Energy, Water and Environment Systems, and we will award the paper which has the highest score in number of citations during 2 calendar years following the year 2018, which is the publication year. And besides a book from a member of International Scientific Committee, we also will grant the winning authors of the winning paper, which we call them SDEWES coins, 2 SDEWES coins, but the monetary value is a fee waiver of publishing. So we will grant 2 fee waivers to the authors to publish in Journal of Sustainable Development of Energy, Water and Environment Systems. And our winner is the paper entitled Energy Transition from Diesel-Based to Solar Photovoltaics Battery Diesel Hybrid System-Based Grids in Philippines. A techno-economic potential and policy implication of missionary electrification by Joy Oxen and Paul Berthau. I think we have the author with us online. If yes, maybe we can invite him, we can give him the cloud to address the audience. Please. Joy, can you hear us? Probably not. Probably they don't hear us. Okay, then I think that, okay, but we were able to see.
Thank you very much. Can you hear me?
Oh yeah, yes, great. Please go ahead.
Yeah, thank you for the recognition on the best cited paper for the Journal of SDEWES. It's an honor to receive this award, and after the publication of this work on the energy transition in the Philippines, it has generated a lot of succeeding work on RE transition. The next SDEWES conferences in Europe when the situation is getting better. Thank you very much.
Thank you also. The award will be sent by post. And now I think we can go on with the best paper awards. Let me just explain the procedure of selecting the papers, our winners. But first I would like to also introduce the other members of the award committee. Professor Antonio Piacentino from Italy, Professor Inge Stadler, Germany, Professor Chihuahua Wang from China, and Professor Alexander Zidanšek from Slovenia. And we followed the two-phase procedure of selection in the first phase, all the editors and reviewers of your paper would have a chance to mark the paper as a candidate for Best Paper Award. And we try to ensure that all the archival contributions are covered with this potential to be selected. So after the first phase, we got a pool of nominations or potential candidates of about 40 papers. And then in the second phase of selection, the members of the award committee enter the stage and they do individual evaluation of the papers. First, each member selects 2 papers out of those 40 in the pool, and then we come to a pool of 10 papers which are very deeply considered by the members of the award committee, and they provide their marks or scores. And after that, after the individual evaluations, the papers are ranked according to their scores. So that's the way how we select the top 3 papers. The third best paper is a paper which works on identification of the foremost F-gas refrigerants for vapor compression technologies, and is authored by Nicole Miranda, Giovanni Palax Alcantar, Radhika Khosla, and Malcolm McLeod. I'm sorry, maybe I was not very correct in pronunciation. But we have a female researcher as the first author, and the paper, the authors come from institutions from UK. I think we have the winner. Yes, Nicole, please join me at the stage to receive your award. Congratulations. Thank you. And also, besides the certificate, we will award our winners with a book from Professor Jiří Klemeš, Sustainability in the Process Industry, Integration and Optimization. Congratulations. This is your award. And please.
Thank you very much. Hi, everyone. I would like to first thank the Oxford Martin School who funded the Future of Cooling program, which I am a member from, and where we work with my co-authors, Professors Khosla, McCulloch, and my research fellow, Dr. Palafox Alcantar. Thank you to the Energy and Power Group, where I sit in the Department of Engineering. And last but not least, thanks to the committee for organizing this conference, but also these very meaningful awards. And I think this is a great recognition of how important and significant is our work on refrigerants. I invite you all to go and see the presentation on Thursday, where I'll be reporting some important factors that we should consider when reporting refrigerants. These are really potent greenhouse gas, and we have to focus on reporting well their warming potential. So thanks very much again, and see you around.
Thank you. Second best paper, it deals with coupling of a road solar thermal collector and borehole thermal energy storage for building heating, and presents the first experimental results. It's authored by Alessandro Bossimi, Giuseppina Giulia, Antonio D'Amico, and Marco Becciali. I think the author is on Zoom, but maybe we have somebody to accept the award on behalf of authors. Sylvia? Yes. Okay, we have Sylvia to accept the award. Congratulations. This is the award. Yes. Welcome. And I would like to invite Alessandro Boscimi to address the audience.
Okay, good morning, everyone. I'm very honored for this award. I would like to thank the SDEWES committee for this recognition, and also thanks the whole team at the engineering department of the University of Palermo in Sicily, where I work. So thanks.
Thank you. Can you change? And now, yes, again, the book was, which was awarded is Renewable Energy Systems, second edition, a smart energy systems approach to the choice and modeling of 100% renewable solutions by Professor Henrik Lund. And best paper, this time the award again goes to authors from United Kingdom. The paper practically presents a critique review of renewable generation technologies and their impact on dynamic grid stability in power systems with 100% renewable generation. It is authored by Fardum Ahmed, Aoife Foley, Sean McClune, Robert Best, Shi Cameron, and Dal Arcaez. I think we have the first author with us on Zoom, and I would like to pass the cloud to him to address the present people.
Yes, thank you for this award. I would like to give my special thanks to the committee for selecting my paper, and it's a great honor for me to be selected as the best paper award by the committee. And I would like to give my special thanks to my supervisory team because of the comment and the revision. My paper has been rewarded. Thank you a lot, and I'm proud of your conference as well. Thank you.
Thank you.
Thank you.
Thank you also for this great success. And about the gender balance, I'm very happy that we have one female first author. One of the winning papers with the first author is a female researcher. And also about the geographical distribution, we were not that much successful. All our papers are coming from Europe, but it somehow can be justified that even the participation is mostly related to countries from this continent. And now we will again, sorry, the book presented to to the best paper is again Renewable Energy Systems from Professor Henrik Lund, which we believe that will help our authors, the researchers, to deepen their research further on. And now we can invite our most loyal participant. This is for this year, this time it's Professor Sebastian Verle. And the statistic says that he participated in 7 SDEWES conferences in a row, so it's our most loyal SDEWES participant. And I would like to invite Professor Sebastian Verle to receive his well-deserved award.
Okay, it's great pleasure for me and great honor for me to be here. First of all, thank you very much, committee, for such nice award. Since my first time in the conference, I was pretty sure that it will be nice events. Congratulate to Person Deutsch for such idea and organize that nice conference. So once again, thank you very much, and I hope also next 7th, at least, conference will come with me, so thank you very much.
Okay, so I've just heard that we have the winning author of the most cited SDEWES paper, so we can also invite him to take the cloud and to address the audience. Please, Berard.
So good morning to everybody. For those of you that are in European zone, good morning actually to all the other people. It's a great pleasure and also a great opportunity for me to join you this morning. My name is Umberto Berardi, and I heard that there is one of the co-authors that somehow has already been able to collect this award in the audience. I work in Toronto, and as far as I know, this award was announced very recently, so it wasn't really easy for me to organize myself, but as it's important, we need to acknowledge the SDEWES conference, the SDEWES members, and the SDEWES panel that has been giving it such an honor to be recognized. And I likely wish to be there, but eventually we will see soon again together, and I hope that you are going to join this Paphos conference in the next few days. Thank you so much.
Thank you also. And I think we still have time for yet another round of applause. Please join me in yet another round of applause for all our awardees. And also, I would like to invite the awardees and the present members of the award committee for a joint photo. And with this, we close the award session. Thank you very much for joining us in this appreciation of the success of our awardees. Thank you.
Thank you, Natasha, and congratulations to our winners. So the last thing on the agenda is a group photo. However, as I understand, outside is raining, so I will ask Tomislav to give us an update on the weather conditions and see how to get over it.
Okay, thank you, Soteris. Outside is pretty bad regarding weather. We actually, I think it looked like a tropical storm in like half an hour ago. Now it's a little better, but it's still raining. So we will switch our group photo from the terrace that we initially planned to a room. If you were on the welcome reception yesterday, it's the place where the food was served. It's right next to the terrace. The local organizing committee people will point you to the directions, so just go outside. We will do a very quick group photo, like 2 minutes, and then we go back to the coffee break, and then you can continue with everything. So let's go for a group photo, and then we continue with everything else. Meanwhile, awardees can just come in front here to have a joint awardees group photo, and then we can go to the actual group photo.
The piše ovo award. Ne, ovo.